All right, on 21, it says we are at a sand and gravel plant, and sand is falling off of a conveyor belt onto a conical pile at a rate of 10 cubic feet per minute. Let's talk about that rate. What rate did they give me there if it's 10 cubic feet per minute? Volume. Very good. What's the dead giveaway that it's a volume rate?
Cubic.
Cubic. Very good. Very good. All right. And it says it's falling into what type of pile? Conical pile. All right, let's keep that in mind. It says the diameter of the base of the cone is approximately 3 times the altitude. So the diameter of the base is 3 times the altitude. But if we're talking about a cone, what do we want to use instead of an altitude? Height. So diameter is 3 times the height. It says at what rate is the height of the pile changing? So what is it they want me to find?
Derivative of the volume of the cone.
You're not answering my question. What rate is it they want me to find when it says at what rate is the height of the pile changing?
The rate at which it's getting higher.
Right, so what is it? Which one is it? How do I represent it? dH over dt. So dH over dt is what they want me to find. Okay, and it says when the pile is 15 feet high. So what is 15?
The height.
Height is 15 feet. Okay, so now I've written down all the information I have. In order to move forward, what do I need?
The area of
The
volume
radius.
formula for a cone.
I need the volume formula for a cone, is what I need. The volume formula for a cone is 1/3 pi r squared h. Okay? And if you look at that formula or that equation, what's different about it versus the equations I dealt with yesterday? It does have an h on it, but what's different about the right side versus the right side of yesterday's stuff?
It's not an improper fraction. It's got an h. H by itself.
I got 2 variables on the right side. Yesterday, everything on the right side had what? One variable. Okay? When I run into something that has 2 variables on the right side, what I need to do is find a substitution to make. That way I'm only dealing with 1 variable on the right side. And that's where that other piece of information came, why they gave that to me, is I'm going to find it from that. The other piece of information they gave me is that D equals 3H.
D equals 44.
Okay? What does D stand for? Diameter. But my equation deals with radius. So what do I want to replace diameter with? 2r. So this is really 2r equals 3h. Now, what do I want to get rid of? Do I want to get rid of the r or do I want to get rid of the h?
The R, because you need the H.
What do you mean get rid of?
Like I need to make a substitution to where this only has h in it or it only has r in it. So I'm saying which one do I want to get rid of? The r or the h? Why do I want to get rid of the r? Because I'm looking for dH dt, and they gave me what h is. So that means I want to get r by itself over here, which is 3 over 2h, and now I can substitute that back into my volume formula, and I'll only be dealing with 1 variable. That's the difference between the stuff we were doing yesterday and the stuff we're doing today. Everything else is the same, except that there's going to have to be a substitution to go from 2 variables to 1. So if I make that substitution, I've got pi, I've got 3 over 2h, that's squared times h. So if I square this, this becomes 9. The 9 and the 3 reduce and give me 3 pi. If I square 2, that gives me 4, and then h squared times h is h cubed. So now I have the volume formula, and I'm only dealing with 1 variable on the right side. now that I've gotten to this point, what do I want to do next?
Derivative.
Find the derivative. So derivative of b is dv dt. Derivative of h cubed, that's going to be 9 pi over 4 h squared dh over dt. Once I take the derivative, what do?
Get h by get dh dt. Plug in.
I plug in. So I'm going to move over here. dv dt is 10. H is 15. Then I have dh dt. All right, so I multiply the 4 over, it gives me 40, and then I divide by 9 pi and 15 squared. And that gives me dh dt. Now, what are my units if we're talking about dh dt?
Oh no, it's just a stop.
Feet.
I'm just talking about a height. So what is height? Feet. And my time was minutes. So dh dt is 40 over 9 pi times 15 squared feet per minute. Okay, now what does that tell me?
That's how fast your height is changing.
All right, what does it tell me about my height?
It's going,
Besides how fast
it's
it changes.
increasing.
My height is increasing because,
Derivative.
be more specific,
The derivative of the height is positive.
be more specific. What equals 40 over 9 pi times 15 squared?
The rate in which it's changing.
But what is it right there? dh over dt is positive.
Said
That's what I want to hear.
derivative.
That's not what I want to hear though. I want to hear the height is increasing because dh dt is positive. That's what I want to hear. I'm going to be asking that question over and over again. Yes?
Could we use that H prime there, or do you want us to?
I want dh dt. If we're dealing with time, I want dh dt. All right, next problem, which is going to be 24. Okay, but again, that's the difference between today's problems and yesterday's problems, is you're going to have to substitute out a variable to go from 2 variables to 1 variable. That's the difference between yesterday and today. 24.
Dead.
Says we have a trough that is 12 feet long and 3 feet across the top. See the figure, so above you see where it says figure for 24. Its ends are isosceles triangles with altitudes of 3 feet. Alright, so let's look at part A. It says if water is being pumped into the trough at 2 cubic feet per minute. What did they just give me in 2 cubic feet per minute?
The rate in which water is being pumped in.
Right, what can I represent that with?
dv over dt,
And how do I know that?
that's cube, or the cubic.
It's cubic. So dv over dt equals 2. Is it centimeters or feet?
Feet.
So 2 cubic feet per minute is dv dt. It goes on to say how fast is the water level rising when the depth h is 1 foot. So they're telling me h is 1 foot, but what is it they want me to find when it says how fast is the water level rising?
I wanna know what the
The
depth
rate
is,
that it
dh
takes
over dt.
The water.
Right. When it says how fast, that means it wants a rate. And what is it that's changing?
H,
H, because we're talking about rising. So they want me to find dh over dt is what they want me to find. So now I've written down the information they gave me. I figured out what they want me to find. What do I have to come up with next? I have to come up with the equation or the formula I want to use. So what is the shape of the figure I need to use here?
the triangular figure.
It's a triangular what?
Prism.
Prism. So how do I find the volume of a prism? Very easy.
It's a triangle within its times.
Is it surface area?
Yes.
triangle?
You're right. It is the area of the base times how long it is. So what makes up my base on this? A triangle, so what's the area of the triangle?
1/2 base times height.
1.5 base times height,
Times height.
and then how long is this thing?
12.
12 feet, so times 12. So that means my volume
6 base times
is 6 base times height. Okay, but again, what problem do I run into here? I got two variables on the right, which means I've got to get rid of one and turn it into the other. So I go back and I look at the information they gave me, plus what it is they want me to find, which variable has to stay.
H.
H has to stay, which means I've got to get rid of B. So that means I need to know how is my base related to my height.
on the picture.
How's the base always related to the height?
You use the height boundary.
Look at the picture.
I know on the picture. It's the
We're
base.
talking. We've got a triangle right here. It says it's 3 feet. It's 3 feet across,
And 3 feet deep.
and it's 3 feet deep.
At this point, your base.
So as this thing fills up, what's happening to the base and the height?
The base is getting staying
They're staying proportional. What is that proportion?
1 to 1.
1 to 1. So that means the base is always going to be equal to the
Height.
height.
And the height is 1 foot, so the base is 1
Nope, I don't want to do that.
foot. I know, but
I
the
want to
base is
replace them. I want to replace the two. So that means I can take the base out and put what in its place?
H.
The h, because the base and the height are always going to be equal. So that means my volume formula is just 6h squared.
With H.
That's the hardest part of this whole problem that we're doing today. Is figuring out how to make the substitution to go from two variables to one. That's the hardest part. Alright, now what do I want to do to it?
Take the derivative.
So dv over dt equals 12h dh dt.
And H is 1 foot.
So now I plug in 2 over here on the left. I plug in 1 for the height. And now I just have to solve, so I divide by 12. So I get dh dt equals 1/6. What would my units be?
Feet per minute.
Feet per minute. So it'd be 1/6 feet per minute. Well, why is it feet?
Because we're talking about the weight, the distance of feet in
We're talking about a height, and I measure height in just a unit. In this case, my unit is feet. All right, Garrett, what does this tell me?
Okay, that your thing, something is increasing at 1/6 feet per minute.
All right, what is increasing?
The depth,
The depth is increasing at 1/6 feet per minute. What tells me it's increasing?
says it's a positive sign.
Be more specific. Don't ever use the word it.
Okay, 1/6 is positive.
But what is 1/6?
Your
What is 1/6 equal to?
the derivative of
No. What is it equal to?
D.
Exactly. Up here. What is 1/6 equal to? What is it equal to?
the HCT.
The HCT. I didn't ever hear the
I started saying that you
It's
said
the
no.
derivative.
Yeah. So I want you to tell me that my height is increasing because the HDT is positive. I do not want to ever hear the word it.
It.
The it is no longer allowed to be used in here.
It is my favorite pronoun.
Okay, and what's the easy way to always tell what it is that's increasing or decreasing?
The derivative.
Whatever that is right there, that always tells you what's increasing or decreasing. What does H stand for? Height. So that means my height's increasing.
Slash depth.
Okay, or depth, yes, whatever you want to use. All right, but there is a part B to this problem. Part B, we're no longer going to use that right there. They're going to give me some different information. Part B says if the water is rising at a rate of 3/8 of an inch per minute. So what rate did they give me there? It's 3/8 of an inch per minute.
GH.
dH over dt. What's the they give away that it's dH over dt?
The height is just
It's just the unit inch. So that means it's gotta be the height. So 3/8 of an inch per minute is dH/dt. And it says when the height is 2, so this is 2, it wants me to find the rate at which the water is being pumped into the trough. So what rate do they want me to find? dV over dt, that's the only rate that's left. So they want me to find dV dt. So I get to use the same equation because we're still using volume. So I just need to plug in my new information. So dV dt is what we're looking for. My height is 2. And what is dH dt? 3/8. But what's the problem with 3/8?
That's in inches.
It's in inches instead of feet. So what do I do to change it from inches to feet?
Multiply by 1/12.
I multiply by 1/12.
Or divide by
1/12 or 1/2?
1/12, sorry. Everybody okay where we get 1/12 from?
12. And the 1/12 cancels.
Because I've got inches on top. In order to get rid of inches, I need inches on bottom, and I want to replace it with feet. So in order to cancel out inches, there are 12 inches in 1 foot. So that's where the 1/12 comes from. So the 12 and the 12 cancel, the 2 and the 8 cancel, and I end up with 3/4. But what is my unit?
Feet cubed.
Feet cubed. Alright, so Amelia, what does that tell me?
That it's increasing.
You said a bad word.
That the volume is increasing.
Volume is increasing, and what tells me the volume is increasing?
dV over dt is positive.
dV over dt is positive. That's exactly what I want to hear you guys start giving me. Exactly what I want. Very good. Alright, let's look at 25, and then we'll be done with 25. Or we'll be done after 25.
Oh, 3 parts.
There are 3 parts to it.
Oh. Moving ladder.
25. It says we have a ladder that is 25 feet long, and it is leaning against the wall of the house. See the figure. So down there below it says figure for 25. You got the house and the ladder.
This ladder's falling.
Okay? And the base of the ladder is being pulled away from the wall at a rate of 2 feet per second. So let's draw this triangle we got here. What do we know about this triangle?
The right triangle.
It's a right triangle.
This is not the wrong one. It's
What else is it?
sliding down. Your hypotenuse is 25 feet.
All right, my hypotenuse is 25 feet, and then I need to label my 2 sides. What do you want to label those 2 sides?
Base bottoms are
So we'll call the base, the bottom, the base,
and
and we can call the other side the height.
well, maybe it has R on there.
I don't know. It's just telling you. I don't know why it says R. I don't like it.
Maybe that's like.
All right, so let's go back.
Falling.
Let's go back and read. It says the ladder is 25 feet long, leaning against the house. The base of the ladder is being pulled away from the house at a rate of 2 feet per second. So what rate are they giving me there with 2 feet per second?
Your height is your H is getting larger at 2 feet per second.
Nope.
They're giving you
What is changing? What are they telling you is changing?
Base is changing.
The base is changing. So what is that?
And
If the base is changing, that means we're talking about dV over dt, and it was 2
feet per second.
feet per second. All right, part A says, how fast is the top of the ladder moving down the wall? What is it asking me to find? If it says, how fast is the top of the ladder moving down?
Rate of DH would
dH over dt, good.
be
Okay, how fast is that moving when its base is 7 feet? We're only going to do the 7 feet one. So when the base is 7 feet, so B is 7. So there's all the information they give me. Now that I have the information, what do I need?
your formula.
I need a formula. So if I'm looking at that triangle over there, what formula comes to mind?
1/2 base.
The area formula might, but we're just dealing with, what 3 things are we dealing with right now? Sides. So I need a formula that only deals with sides, which would be the Pythagorean theorem. So I would get h squared plus b squared equals 25 squared.
Only B seven.
Okay, now what do I want to do?
Take the
Or
derivative.
Take the derivative. So I get 2h dh dt plus 2b db dt. And then 25 squared, what's the derivative of that?
2 times 25.
0.
But it's still a constant.
Got it.
Right.
It's a constant. So now I just plug in 2 times my height. Do I know my height right now?
No.
No, we'll come back to that. dh dt is what we're looking for. 2 times my base, which is 7, and dB dt is
2.
2. So if I get to something like this where I need the height and I don't have it, what do I do to get it?
Plug in the B.
7 into
Go into your Pythagorean theorem.
I go back to the Pythagorean theorem
Let's go.
and plug 7 in.
Yeah.
So if I plug 7 in, that gives me h squared plus 49 equals 625. That gives me h squared equals
76.
576, and the square root of 576 is 24. So now I just need to get dh dt by itself. So 2, that's 4 times 7, negative 28, and 2 times 24 is 48 units,
Feet per second.
feet per second.
Do you have to simplify that?
No. Melody, what does that tell me?
That the height is increasing because
No.
decreasing because
Decreasing.
h over dt is negative.
Excellent, that's what I want to hear. The height is decreasing because dh over dt is negative. Good.
Let's take out.
Anyway, it's
Double.
already written.
Nice.
Now you almost made him have a heart attack.
Next part. Next part of this problem. Part B. Part B says, consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing. So what do they want me to find this time?
Area.
dA over dt. So they want me to find dA over dt. When the base of the ladder is 7 feet from the wall. So again, my base is still 7. They want me to find dA dt. So I have all the information I need. What do I need to go forward?
You need the
Area.
I need the area formula. So what's the area formula of the triangle? It is 1/2 base times height. So what's the problem?
You have 2 variables.
I've got 2 variables on the right, but it's actually not a problem in this case.
Does that give you what?
Because the reason why I don't like 2 variables is because I end up with 2 rates over there that I need to know. But what did I just do on part A? I found the rate of H and I found the rate of B. So I've got both rates, so I don't have to get rid of one of them on this time. If you've got both rates, you don't have to get rid of the variables. In this case, I've got both rates, so I just need to find the derivative. So dA over dt, the 1/2 stays there. What do I have to do with B and H, Garrett? Since it's B times H, what do I have to do with it to find the derivative? Shh. What's going on with B and H?
Maybe what do you have to do the part?
Thank you. So first times the derivative of the second plus the second times the derivative of the first. There it is. Now all I have to do is plug in. So dA dt is what I'm looking for. I've got 1/2. My base is what? 7. What is dH dt?
Negative 7 calls.
28 over 48.
Okay, what's my height?
24.
24. And dB dt is 2. Now work this out.
That's a lot.
I think it was 21 something. see if I can find it. Oh, there it is. 21.958. Okay, what are my units there?
Areas.
Area, so it needs to be squared, so that's feet squared per minute. Hi, Jairus. What was that telling me?
Uh-oh.
Areas increasing because the A over DP is
Very good, thank you.
It's
All right, part C.
Wait, Coach White, I have a question. dB over dt is feet per second, but your answer is feet squared per minute.
Oh, was it second? Sorry.
Yes, and Pepper
Yes,
voice.
should be in second. Thank you. All right, next one, last one. All right, C says find the rate at which the angle between the ladder and the wall of the house. So what angle are we talking about between the ladder and the wall of the house?
I guess it's with the
B
arc.
and 25.
The top one.
That's
And what do we represent an angle with?
Little,
One of those
little arc circle.
Yeah.
Theta.
Net.
All right, find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 7 feet from the wall. So what is it they want me to find this time?
Angle. D theta.
D theta over dt. Good.
I know, D theta. Root of theta.
So what do I need to proceed? I need something that has an angle in it.
Oh,
It's a bill with a triangle.
sine of
All right, let's talk about what sides that we know. What are they giving me? They said when my base is what?
7.
7. So since they want me to use my base and they told me my hypotenuse is 25, so I want to use those two sides. What's the trig function?
sine.
Sine. So sine of theta equals b over 25.
7.
Yahtzee.
All right, now what? Now that I have my formula.
Now you move the 20,000 for the sun.
No, you find the derivative.
Find the derivative. What's the derivative of sine?
Theta cosine
No.
I thought it was cosine theta. What is it?
Cosine theta,
You
theta.
tell me.
I like
Of d theta.
d theta over dt.
You tell me.
Just remember, you got to take the derivative of the inside.
0.
Okay, what's the derivative of b over 25? What's another way to write b over 25?
B times
1/25 of B.
1/25 times b. So what's my derivative going to be? 125, 1/25 dB over dt.
So much.
Okay, we know that dB over dt is,
2.
so this is 2 over 25. So the only thing we need to figure out is,
The cosine.
what's cosine? What's the definition of cosine?
Adjacent over hypotenuse.
So what would adjacent over hypotenuse be?
Height over 25.
So it's.
So what's my height?
7.
No, you said it was
No.
24, right?
24.
24, and my hypotenuse is
What's your base then?
25. So I multiply by the reciprocal, the 25s are going to cancel, I get 2 over 24. And so that gives me 1/12. What would my units be?
1/12 feet.
Degrees.
We don't use, in calculus, we use radians.
Radians
So
per second.
Radians per second.
Oh,
Why do you use radian?
because we're in calculus.
Is it easy to calculate?
We'll get into it later.
Okay.
All right, Brian, what'd we learn? Well, I want exactly.
I mean, I know it's because it's increasing.
What is? Quit saying it.
Theta is increasing because d theta over dt is positive.
Very good. My angle is increasing because d theta over dt is positive. That's what I want to hear.
This is where.
That's a lot.
Got it?
There's still more.
No, there can't be more.
That's it.